Hello. This video is for IXL activity 6.Z.7. It is titled Solve One-Step Addition and Subtraction Equations with Whole Numbers. The 3-character code for this activity is Juliet X-Ray Mike, JXM. On this activity, we're going to be doing equations that take only one step to solve them. They will include either addition and subtraction, which works well because addition and subtraction are inverse operations to each other. We can undo addition with subtraction and subtraction with addition, so that's what we're going to be doing. And all of these problems involve whole numbers. Remember that whole numbers are numbers like 0, 1, 2, 3, 4, 5, 6, 7, and into positive infinity and beyond. So we'll go ahead and start off on the first one here. So 17 equals w plus 2. We're going to rewrite the problem. 17 equals w plus 2. We see that the 2 is tied to the w through addition, and the inverse operation for addition is subtraction, so we'll use subtraction to undo the addition. And we're going to subtract the very number we wish to get rid of, which is 2. And whatever we do to one side, we have to do to the other. So we go ahead, set that up, and these 2's will cancel each other, leaving us with just w on the right. And 17 minus 2 is 15. So we end up with w equals 15. Yes, we can flip those around. The w doesn't have to stay on the right. I prefer my variables to be on the left with the equal sign and then the solution. So I always put my variables on the left whenever I enter my answers. On the next one, 5 equals y minus 13. So let's rewrite the problem. 5 equals y minus 13. The 13 is tied to the y through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, which is 13, because remember the object is to isolate the variable y. Isolate means to get it all by itself. So I'm adding 13 to the right, and what I do to one side, I need to do to the other. Just like if I had a scale, if I'm going to put something on one side to keep it balanced, I have to put the same thing on the other side. So here I'm adding 13 to negative 13, so those are going to cancel each other, leave me with y, and 15 plus 13 is 18. So if you want to ever check your answer, y equals, and oh, I just noticed they already have the variable there for me, so y equals 18. So over here, I didn't need to type in y equals. I just need to put 15. There we go. Now, if you want to check and make sure, so because especially once you get up into the higher scores of IXL, you know you lose more points for missing the more difficult questions. You can always make sure your answer is correct by substituting the answer back into the question and evaluate it and see if it makes a true statement. For instance, 5 equals, and y is 18 minus 13, and 18 minus 13 is 5, so it checks out. So before you ever hit the enter button, you can make sure your answer is correct by substituting your solution back into the equation and seeing if your solution satisfies the equation. That is to say, you get a true statement that some number equals some number. Here we have h minus 56 equals 11. So the 56 is tied to the h through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, and what we do to one side, we do to the other. So let's go ahead and work that out. 56 is going to cancel each other, leaving us with just h on the left. And then 11 plus 56, well, 56 plus 10 is 66, plus one more is 67. So h equals 67. Let's rewrite the problem. J plus 28 equals 979. So the 28 is tied to the j through addition. The opposite operation is subtraction. I'm going to subtract the very number I wish to get rid of, which is 28. And what I do to one side, I have to do to the other. And now the 28's will cancel each other, leave me with just the j. And now I need to do the subtraction over here. So 9 minus 8 is 1. 7 minus 2 is 5. And let's bring down that 9. So j equals 951. Here we have 901 equals v plus 234. So rewrite the problem. 901 equals v plus 234. So the 234 is tied to the V through addition. The opposite operation of addition is subtraction. And we're going to subtract the very number we wish to get rid of, which is 234. What we do to one side, we are going to do to the other. All right, so let's see what happens here. The 234s will cancel each other, leave me with just V on the right. Now I need to subtract 234 from 901. So 1 minus 4, can't do that. I'm going to need to borrow. So this becomes an 8, and this becomes a 9. And 11 minus 4 should be 7, right? Yep, 7. 7 plus 4, 11. Yeah, I'm having a brain cramp there. 9 minus 3 is 6, and 8 minus 2 is 6. So V equals 667. And we could always plug that in and say to 667 plus 234, 667 plus 234. If I did this correctly, I should end up with 901. 7 plus 4 is 11, carry the 1. And 6, 7, 10, carry the 1. 8, 901. Indeed, 667 is the correct solution. So here I have Q minus 49 equals 151. The 49 is tied to the Q through subtraction. The opposite operation of subtraction is addition. I'm going to add the very number I wish to get rid of, which is 49. And what I do to one side, I need to do to the other. So the 49s are going to cancel each other, right? So we'll cancel those out. We end up with just Q on the right. Now we have 1 plus 9 is 0. Carry the 1. 5, 6 plus 4 is 10. Throw on another 0 there. Carry the 1. And we end up with 200. So 200, Q equals 200. My last two examples here, T minus 430. So T minus 430 equals 125. And the 430 is tied to the T through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, which is 430. And what we do to one side, you've guessed it, we're going to do to the other, 430. So go ahead and work that out. So the 430s will cancel each other, leaving me with just T. And then 125 plus 430. 5 plus 0 is 5. 2 plus 3 is 5. And 1 plus 4 is, well, all 5s. 555 is the solution. T equals 555. All right, so rewrite this. M plus 247 equals 798. All right. So, yeah, I know you're like, I know. The 247's tied to the M through addition. We're going to use subtraction. We're going to subtract the number we want to get rid of. What we do to one side, we do to the other. Yes, it's almost like Dora. Through the trail, past the rock, over the bridge, and across the creek. Through the trail, past the rock, through the river, just the same process over and over again. So it's kind of like Dora and her map finding her way. However, it works. So if you just remember the process, it's kind of like baking a cake. Math is like baking cakes and doing all kinds of things. You just follow the recipe, follow the process. So the M is tied to the 247, or the 247 is tied to the M through addition. The opposite operation is subtraction. We're going to subtract the very number we wish to get rid of, which is 247. And what we do to one side, we're going to do to the other, 247. What's that leave us with? Well, the 247s are going to cancel each other, right? Leaving us with just M on the left. And then 798 minus 247. 8 minus 7 is 1. 9 minus 4 is 5. And 7 minus 2 is 5. So M equals 551. And those are all my examples for IXL 6.Z.7, and where we are solving one-step addition and subtraction equations with whole numbers. Good luck with your activity.